Section 15D, question number 2, page 371. In this question we're asked to find the gradient to the tangent to these functions at specific values. First question, part A, y equals, the function is y equals x over 1 minus 2x, and we're evaluating the gradient of that tangent to this curve at x equals 1. So go ahead and differentiate this. Find the gradient function by using the quotient rule. So take the derivative of the top, which is 1, multiplied by the bottom. Then I subtract the top multiplied by the derivative of the bottom, which in this case is negative 2, all over the bottom squared. Now I'll simplify this a little bit to make the substitution and the subsequent evaluation of the gradient at that value a little bit easier. So we're going to then just expand this in, so we're going to have 1 minus 2x, and then negative 2 times negative x gives me positive 2x all over 1 minus 2x all squared. Negative 2x plus 2x is the zero pair, so that disappears, so we're left with 1 over 1 minus 2x all squared. Now I'm going to find the gradient of that, so I'm going to evaluate dy by dx at x equals 1, and so then I'll just substitute 1 in to where I see the x, and then I'll just simplify this a bit. So we have 1 over 2 times 1 is obviously just 2. Negative 2 all squared. And then we get 1 over 1 minus 2 is negative 1 squared, which then just leaves us with 1. So the gradient of the tangent to this curve at x equals 1 is 1. Moving along to part B, we will see that the function is y equals x cubed all over x squared plus 1, and we're evaluating this, or the gradient to this curve at x equals negative 1. So the derivative, the gradient function, is 3x squared. That's the derivative of the top multiplied by the bottom, x squared plus 1, minus the top multiplied by the derivative of the bottom, which is just 2x, all over x squared plus 1 all squared. So we'll see if we can simplify this a little bit. I don't have to do a whole lot here. I guess I could if I really wanted to, but I'll just leave this pretty much as it is. I'll just bring this stuff together here to get negative 2x to the power 4. And leave that the denominator like that. And then what I'll do is I'll just then evaluate the gradient by substituting x equals negative 1 into the function. So I have 3 quantity negative 1 all squared, quantity negative 1 squared plus 1 minus 2 quantity negative 1 to the power 4 all over negative 1 squared plus 1 all squared. Now I'll just do a couple more steps to simplify this a little bit. And so we have negative 1 squared is just 1, times 3 is 3, and then we got negative 1 squared plus 1 is 2. And then here, negative 1 to the power 4 is just 1, times negative 2 is negative 2, all over, and then 1 plus 1 is 2, all squared gives me 4. So then 3 times 2 is 6, minus 2 is 4, 4 over 4 equals 1. In part C, y equals root x over 2x plus 1, and we're evaluating the gradient of the tangent to that curve at x equals 4. Before I start taking the derivative here, I'm going to rearrange or change the form of that root x to x to the 1/2. And now I will use the quotient rule. So I take the derivative of the top, which is 1/2 x to the negative 1/2, multiply by the bottom, 2x plus 1, subtract the top, multiplied by the derivative of the bottom, all over the bottom squared. And I'm not really sure if I want to do a whole lot of simplification. Actually, I'll probably do none in this case. We're going to find the gradient when I evaluate the gradient function at x equals 4. So I'll just substitute 4 in everywhere. Well, almost everywhere. And then we'll see how this all turns out in the end. So there's the substitution, and now I'll just do some of the evaluation. So we have that 1/2. 4 to the 1/2 is 2, but we've got the negative exponent which flips that, so it gives me 1/2. And then I've got 2 times 4, which is 8, plus 1 is 9. And then over here I've got 4 to the 1/2, which is 2, so that's the square root of 4, times 2, all over 2 times 4, which is 8, plus 1, which is 9, and that's all squared. And then we'll simplify this a little bit here. 1/2 times 1/2 times 9 is 9/4, minus 4, all over 81. And then, I'll just go sideways here. 4 is just 16 over 4. So we got 9 over 4 minus 16 over 4, which gives me negative 7 over 4 over 81. And that gives me then negative 7 over 324. And in part D, y equals x squared over the root of x squared plus 5. And we're evaluating the gradient to that curve at x equals negative 2. So I will again write this in exponent form, like that. And then we will differentiate this. We'll find the gradient function. So dy by dx is, again, the derivative of the numerator multiplied by the denominator minus the numerator multiplied by the derivative of the denominator. Now in this case we're going to have to use the chain rule. So bring the 1/2 down in front, leave the inside as it is, subtract 1 from the exponent to get me negative 1/2, and then I'll go on the inside and take the derivative of in here, which gives me 2x. And that is all going to be over, nice straight line there, x squared plus 5 to the 1/2, all squared. So I'll just do a little bit of simplification here before I start substituting in values. So the first part will just stay the same. And then here I've got 2x times 1/2, which is just x, times negative x squared, which is going to give me then negative x cubed. And that's going to multiply by x squared plus 5 to the negative 1/2. And then the 2 times 1/2 as a power of a power just disappears, so we're left with, in the denominator, x squared plus 5. Now I will evaluate this to find the gradient. Evaluate that derivative at x equals negative 2. So substitute negative 2 where appropriate. And do some calculating here. Leave a square bracket there. Negative 2 squared plus 5 to the negative 1/2. And that is going to be all over negative 2 squared plus 5. Okay, so we're going to continue simplifying here. So I'm going to have 2 times negative 2, which gives me negative 4. Then inside I'll have negative 2 squared, which is 4, plus 5 is 9, and then take the square root of that, which gives me 3. And out here I'll have negative 2 cubed, which is negative 8, times the negative 1 there to give plus 8. And then over on this side I'll have negative 2 squared, which is 4, plus 5 is 9. Take the square root, which is 3, and then the negative exponent flips that, so we get 1/3 there. And then in the bottom, negative 2 squared plus, negative 2 squared plus 5 is once again 9. Seeing a little bit of deja vu there. And so now we'll just simplify a little bit. So we got negative 12 plus 8 over 3 all over 9. And negative 12 is negative 36 over 3 to get a common denominator with 8 over 3. And negative 36 plus 8 gives me negative 28 over 3 all over 9. And then that becomes negative 28 over 27.